Yeah, so we're going to talk about how to just reduce your spend on Azure. And sort of before I start that, just wanted to just briefly explain why I'm talking to you about this and sort of where it's coming from. Just so you understand, it's not all just sort of theoretical. So my business, the Orbit that Dan mentioned, we're local Oxfordshire business, and we have been building systems in Azure since 2011. We're a gold partner. What we've also been doing for quite a few years now is working with other companies that are software development companies, like probably what you guys work for. We are sort of an Azure reseller, but we also help with just people getting the most out of Azure. We talk about being sort of the developers Azure partner kind of thing. And one thing that has proven very popular with our clients is for us to go in and just try and look at what they're spending money on in Azure, and then help them to reduce that cost. And it sounds like marketing speak, but it's genuinely true. We usually find between 30 and 70% worth of cost savings, which, and I mean, the amount of money some people spend on Azure because they click on the defaults and stuff is quite mind-blowing sometimes. So what I'm going to take you through tonight is quite literally the process I would go through, or one of my colleagues would go through when we go into a company to do the cost review, just cut down to sort of, about an hour or so. So I hope that all makes sense. Just want to explain it's sort of, this is all based on very real, very painful experiences in the real world, not just a bunch of theory. So what we're going to do is go through sort of 3 steps. Number 1 is just to actually understand where the money goes and look at the, this is sort of an introduction to the cost analysis tool in Azure, which most people don't know about, and just sort of try and show you how you can figure out where the money goes, because I could give you a list of 200 things that you can do to save money in Azure, but if you're only spending £5 a month on something, there's no point in you going and changing it. Well, so the key thing, first of all, is to find out what is actually your big ticket items, and then start there, and then go and figure out how can we save money on those bits. And then I'm going to take you through this kind of checklist, when we say, when you have found out you're spending a lot of money on X, these are the questions you should ask yourselves, and the approach you can do to try and figure out how to save money on that thing. And then finally, after the break, I'll talk a little bit about some architecture choices that you can do to reduce cost, and some of the things we have found where simple programming mistakes people make that increase cost in Azure. I hope that all makes sense. So let's get stuck into that. So before I do, just want to say, I really wish there just was a button I could just press this button. There's one magic trick to save money in Azure, and it really isn't like that. It is quite genuinely a matter of a structured approach, and there's work involved in doing it, but it is often possible to save quite a bit. So the first thing is, where's the money going? And what we'll do is, so that basically is using the cost analysis tool, which I'll show you in a minute. And I sort of always go through 3 stages. The first one is to identify what are sort of the main types of spend you are having. Are you spending money on compute, on storage, on databases, that kind of thing? And does that look sensible? And in my general experience with general business purpose systems, it is usually the case that somewhere around a third is compute, i.e. VMs or app services, that kind of stuff. About a third is databases. These days, about 10% on logs, and then everything else is about 20%. It's not always the case. Sometimes it's very different. But there's always the first thing to look for. If the mix of the system I'm looking at is vastly different from that, it's usually an immediate red flag. Like I went into a client where like 70-80% of their cost was in the database, and there was a good reason for that, because they were doing something quite bad with the database. The next thing then to do is, okay, so now that you know it's in databases or it's in compute or whatever, is then to figure out what actual resources are the expensive ones, and figure out whether they need to be that expensive, whether they make sense, whether there's a reason for it, or whether there's just some bad choices. And then the third thing is to, sometimes it's quite useful to drill into, for a particular type of spend, how it's made up, because it turns out in Azure that, especially for the PaaS stuff, there's so many different things that go into making up the cost, the number of pricing models they have, and sub options that all contribute to cost. So to try and drive in and figure out, is it, the storage or the compute or the network or whatever it is, what part of it is that's costing them money, can be exceptionally helpful in trying to figure out how to reduce costs. So the thing about the Azure cost analysis tool is that it is really useful and it is extremely slow. So rather than showing it to you live, I've done a video so that I've been able to cut out a lot of pauses. This video takes like twice as long at least if you do it in real time. Okay, but it is good. So if you haven't seen the cost analysis tool before, if you just go into the Azure portal, type in cost analysis, you will get a view that looks a bit like this by default. And that's very useful for telling you, how much you've spent this month and what it's predicting you're going to spend for the rest of the months. But it's not very good to finding out if you can save money. So to find that out, I'm going to sort of just show you how I would do this, or how I normally do it. If you're used to using this tool, this should all be obvious to you. But if you haven't seen it before, it is very powerful. So for something like, the first thing I do is just go back in time to a previous month, so I get a whole month to play with. Obvious, that's the top. Then I'll change the granularity to none, and then go to group columns. And then I group it by something called service family. And then you'd sit and wait for about 30 seconds, and then you get something like this. So that tells me immediately that in this case, they're spending quite a lot of money on compute, twice as much than on databases nearly. No service family, that's reserved instances, and then storage and security is sort of the rest of it. So that already gives me an inkling that that's a lot of money to spend on compute. So I suspect they're doing something not sensible, and I can tell you that they are. So I happen to know that, but it means that I should probably focus on the compute before I start focusing on databases, for example. And the storage is minimal, so it doesn't make a lot of sense to me to go and spend hours trying to figure out how they can shave a bit of money off the storage cost, because it's so minimal in the scheme of things. Okay, what you can then also do, just to look at it in a slightly different way, instead of service family, there's another thing you can group by, which is resource type. I should, by the way, say that drop-down group by is entirely inconsistent. Okay, you've got to just play around with all the different options in there, because you get all sorts of different things. So you'll see here it talks about now managed SQL instances and compute disks, but again, it's mostly compute, as you can see here. That's the biggest one again, so that's okay, that's consistent. But I often look at both views. It just gives you some slightly different views on it. So now that we know it's compute, let's go and have a look at, okay, what in compute is it? Is all virtual machines. We can tell that from here. So let's go and look at the virtual machines and find out which ones are expensive, find out whether they have one that's just super expensive or whatever it is. So you can add a filter and then go to resource type, and then you wait for quite a long time for that drop down to populate. Much longer than it looks like on the video, I can promise you. And then you type in, virtual machine, and then you have to tick the little green box, right? It's not obvious. If you don't tick that green box, it doesn't work. And then again, we'll then group by resource. So resource means name. Okay, just to be clear, don't search for name, it doesn't exist. If you want to find the thing, you need to do by resource. Again, one of those little things. And then we can see here that I have identified which machine, and I've had to blank that out because this is a client system, but which particular VM is most expensive. And I can see these 4 VMs are the expensive ones. So then I can now start talking to the client about why are these machines so expensive? Are they necessary? And I can look at how utilized they are to see whether they're overspec. There's another view that's useful to do. Let's just get the video to show us that. Which is, instead of these nice charts, the table view is actually really useful. Very boring, but very useful. Because we can then see this is then the list of the virtual machines, but then you can open it up, which I shall do shortly. There we go. And you can now see that it actually shows you that little breakdown of that machine, how the cost is made up. And in this case, it's is mostly just the compute, but sometimes it might have been bandwidth or something else. So that's, again, one of those quite useful things that you can do to just quickly get a little drill in. Those tables are really useful when you want to understand a bit more. So that's sort of the first two steps that I talked about. Now, the third step is to try and understand how the cost of one particular type of resource is made up. And I'm going to use storage for that example, just because storage is the most confounding thing in Azure in terms of, I think there's like 14 different pricing sort of option combinations you can make that all have different price points. So it's really useful to understand that. So as an example, if we wait for my alter ego in the video to click on things. Come on, you can do this. Right, so get rid of the filter. Sorry. That's the problem with not doing it live. So we're going to just look at storage, Azure storage, and I'll sort of just show you the little bit of a detective journey you have to do to figure out how these things are made up. So I'm just going to go back to the columns because they're much prettier with the nice picture, like nice colors and graphs on it. But then we got this thing called meter. So the first thing I would do is look at group by meter to try and understand how is it made up. And you can also see we got this thing down here in the bottom left called service name, where it quite helpfully starts to give us a breakdown. But what you'll see, if I look at just meters, it tells us it's mostly transactions and operations. It's not actually storage that's the big cost. Now that's interesting, because with storage, usually the big cost is in the storing of the data, not the reading and writing. And that's one of those things, as I said, about with storage, you pay separately for operations and for the data storage. So that's already interesting. There's something about how they're using it that is a bit unusual. So to find out more, we can try and group by the meter category instead, because there's a lot of different ones, and it's, as I said, entirely inconsistent for different resource types what they mean. But what you'll see is that's really interesting. Actually, the majority of the cost is from the advanced threat protection, which is one of the security tools they've switched on. In fact, they're paying more for the security tool than they are for storage itself. So again, one of those, that's interesting. It's probably good they're doing it, but it's interesting. And you can also tell that they are paying essentially nothing for bandwidth, which again, people often worry about how much they're paying for bandwidth, but it's usually nothing, but this can confirm it. And then finally, I go and just look at the meter subcategory. And, oh, hang on a minute, that's interesting. Because it turns out that it's actually Azure Files that is costing the money. Now, so I don't know if you know Azure Files, but there's Azure Blob Storage and Azure Files. It turns out Azure Files is significantly more expensive than Azure Blob Storage. So what this has now already told me is that this application is using Azure Files instead of Blob Storage, and therefore they're paying a premium. So changing the application to use Azure Blob Storage will save them money. Now, in this case, 50 quid a month probably isn't worth making the change, but I've seen clients where that is, you add a couple of zeros to that number, you know, and it really starts to make a difference. Okay, so that's really how that's how the cost analysis tool works and how you can drill down. As I said, the key thing is you've got to sort of try keep drilling into it. That group by is just inconsistent. Just try different things and see what results you get, and sort of keep drilling into it to try and find out where your money is going. Now, once we then have once we have then identified, okay, it's compute or it's databases or whatever, then this is the checklist we go through for each service. So we go through right size, right service, scaling, sharing, and so on. And I'm going to run through all of these and say, what are the kind of things we would do in each one to find out whether we're doing the right thing. So the first thing is whether it's the right size. And it's surprising how often we find that people have over-provisioned stuff in Azure, whether it's because it's the old mindset of, oh, I need the biggest thing I could possibly have, or what, I don't know, but it's so common. So one big thing is we often have people have everything on premium. And that's because There are two reasons for that. The first one is, if you go into the Azure portal, it is quite common for Azure to hide the non-premium options. In fact, if you go into the portal now and try and set up a new app service plan, it will suggest all premium options, and you have to click a tiny little link that says show more options in order to get to standard. I've got well over 100 different app service plans in Azure, probably several hundred, and virtually all of them are on standard. So that's the thing. It's a similar thing with, if you look at, say, SQL managed instance, Microsoft will talk about there's standard and there's business critical. Business critical is twice as expensive, but if you actually look at the difference between them in the documentation, there's very little reason for most people to go up to business critical. But Microsoft likes to tell you to do it. You will also find, if you have a little website that has like 5 visitors a month, the Azure advisor will pop up and tell you, oh, you should upgrade it to premium because it's had 5 visitors. Again, pointless. So we find that a lot. So, don't use the premium tiers unless you're sure you need to. And that can often save you 50% right there. Then the second thing is, are you actually having a bigger server than you need to? And I'll show you, most services have a metric screen where you can go and look at sort of how much is actually being utilized over time. And I'll show you an example of that in a minute. And very often you'll find that things are just over provisioned. And again, a lot of the time it's just the habit of thinking that you must have a big server. But the truth is, in the cloud, it's usually a very quick job just to scale it up if you need to. So you don't need to pre-provision way more than you need, but a lot of people do. And you only find out by, as I said, going through this process of drilling into it, finding the expensive things, then look at how much they utilized, and then go through it. And then the final point is actually understanding the different options that you have for a thing. Again, very often people just go through the wizard, take all the default options, and by and large, the wizard gives you the most expensive for everything. So as an example, let me show you the Azure pricing calculator, because that is a tool you should make yourself familiar with if you aren't already. So again, taking storage, because it is a wonderfully convoluted and complex example. So let me show you storage. In this pricing calculator, if I add a storage account, and then I'm just going to, this is every single time you reset it, you have to scroll down to the bottom and tell you what currency you want it in. And I'm just going to change it to pounds. Apologies to any Americans on the call. So this is a good example. So what I would always try and have a look at is, okay, so we use storage in this example. I would actually pull this thing up and just start playing around with the options to understand what cost impact would it have if I changed some options. And then I can start looking at, okay, is it the right thing to change the options? So for example, take standard blob storage. So typically most people have the access to hot, which is for almost all scenarios pointless. If you take this one out, hot is in this case £15 for a terabyte. If I change it to cool, it's £11. But if I change it to let's say GIS, £25 cool, and it's £34 hot. So as you're scaling this thing up, let's just, to make it a bit more fun, let's imagine we have 10 terabytes of data. You can start seeing the differences. And again, most clients I come across, they have their storage set to hot, and basically hot is, as an example, hot is useful if it's cheaper if you access your blobs a lot, but it's not actually noticeably faster than cool. So if all you're doing with blobs is grab them, store them, and access them a few times, cool will have essentially the same performance at a lot less of the cost. The second thing I often see, and again, I'm just using storage as an example, is that people are looking at all of these redundancy options to think, I need the best one, that one. So that's got more letters, right? The problem with that one is, again, it's quite a lot more expensive. And especially, I don't know how many of you here, show of hands, know what the RA means. No, Can't see anyone. Okay. RA means read access, and that means unless you actually write code to take advantage of RA, it is utterly pointless. So don't switch it on. Right? But again, people do because, oh, that sounds cool. So that's what I mean about actually just going and looking at what things have you switched on and make sure that you've switched on the right things. And the pricing calculator can be very helpful. And then you can go look into the docs for what it all means. Okay, I hope that all makes sense. The second, and then the other thing, this is a metrics thing I did from one of our own systems actually yesterday. So what I've looked at, this is a SQL database, and I just went into the metrics screen and had a look at the I'll pay for a system, at how much percentage max it's using of the database over the last 30 days. And apart from a few spikes, we're sort of sitting down here around 30–40%. So that's telling me that SQL database is probably over provisioned, and I should probably dial it down to a lower tier and save myself a bit of money. The only caveat on that with SQL is that you actually get faster performance when you go up the performance tiers, even if you're staying within your performance envelope. SQL is a little bit special. But for most other things, you can just rely on this to say you can just dial it down if you're sort of sitting down there with the metrics. So that's the right. So that's the first thing. That was right size. Then right service. That's a big thing, and often where we find big cost saving. For example, and this is about are you doing the right service for what you're trying to achieve? The first thing is there's 3 different ways of hosting a SQL database in Azure. So you can stick it on a SQL VM, you can stick it on SQL Managed Instance, which has 2 main pricing models underneath it, or you can stick it on SQL Azure, which has 3 main pricing models, and each of those 3 main pricing models has several other pricing models underneath it. Again, the default one for SQL Azure is about 30 times more expensive than the other one, the one that they like to hide under the old tab kind of thing. So again, making sure you use the right service with things, especially SQL on the VM, is really quite a lot more expensive for a bunch of reasons. Usually, there are certain exceptions where it can be cheaper, but normally it's a lot more expensive. Things like storing. So again, you might come across people, and I have, that store files in their database because that's what they're used to doing on-prem. Now, you certainly can do that with a database in the cloud, but it's going to cost you an absolute fortune comparing to storing it in blob storage or something similar. So again, look at those things. And then the last one, as last count, I found about 8 different ways of hosting a website in Azure. And I did come across one client that had they had 2 VMs set up in 2 different regions to carry their one-page website that was the site down page that they used when they took the rest of the system down. So they had 2 VMs running permanently just for this one-page website. Now, that would only have cost them, I don't know, 50 quid a month, but they could have stuck it in an Azure static website for about 2 pence a month. So it's that kind of thing. Just challenge, why are you using that way of doing it? Because very often you can just change it to something else and save a bundle. Right, scaling. So there's manual scaling and there's auto scaling, and then there's scheduled scaling. That's my friend. Scheduled scaling is usually the fastest way of saving money on a system that has size. So here's a good example. So imagine that you have a system with 6 VMs on it, and you need 6 VMs during the day because it's a business system, or during the evening because it's a consumer system. Auto scaling is hard. Okay, it's difficult to do for lots of reasons, which I'll come on to. But if you know that between like 5 p.m. and 7 a.m., very few people use it, you can just set up a scheduled scale to go from 6 VMs to 2 VMs between the hours of 5 p.m. and 7 a.m. You've just reduced your bill by 2/3 for 2/3 of the time. That is very easy to do in most cases, assuming you have that kind of load, and it can give you really big savings very, very quickly without doing anything complicated. So start looking at that before you get clever with anything else. Just do some scheduled scaling and save a ton. Auto scaling is, as I said, much more complicated. You will often need to do some architecture changes for it to actually work well, and I'll come on to a little bit of that later. But you can do it, but doing it on CPU and that kind of stuff is quite difficult. With VMs, it requires you to do a bunch of stuff about scale sets and images and stuff. It's very doable, but it takes work, real work. And I've often found I've recommended it to clients and they've just not done it because they might save £300 or £400 a month, but it's going to take them a week to do the dev work to do it, and it just isn't cost effective, unlike the scheduled scaling. Another thing that surprisingly often I find people scale up their test environments and then they keep them up all the time, even when they don't use them, and they pay lots of money for them. The worst example I have of that is we provided Azure to a company that essentially had a nice brochureware website, and their developers insisted on having 4 different environments set up in Azure: a live, a UAT, a QAT, and a dev environment. And they insisted on them all running 24/7. So we were talking about a brochureware website that ended up costing them nearly $2,000 a month to host, which is insane. All because the developers insisted on having all of these environments all set up, all running all the time. It's more common than you'd think. I had another client, we went in and we looked at it and said, we only spend $4,000 a month. Can you save us some money? Literally went through the thing and we said, you got these 2 databases that are set there. They cost about $1,000 a month. What are they for? Oh, we use them once a month to test our failover in the UAT system. Well, then dial them down while you're not using them for that once a month and save £1,000 a month just by clicking a few boxes. Again, very common. So a lot of this is just looking for the money. And then finally, database scaling, especially dynamically, is complicated. I have some more comments on that on the next page. Generally speaking, though, bear in mind that scaling up and down databases, even manually, is not always straightforward. With SQL, for example, Azure SQL, it usually is quite quick, but I have seen it take over 12 hours to scale up. It just depends on size of it and all sorts of other things. With things like Cosmos DB, you've got to be careful because you can only ever scale down Cosmos to 1/100th of the highest it has ever been. So if you're ever in that, like, oh my word, we have a big disaster, let's just dial out the Cosmos database way up to deal with it for a few days, you might find yourself having a big problem afterwards because you can't get it back down to normal. So again, just things to be mindful of. Databases are beasts as far as scaling is concerned. That said, Azure has got a lot of elastic scale or consumption plans you can use, and they're really good for certain scenarios. So the one thing to bear in mind is that they're more expensive per unit. So let's take an Azure App Service consumption plan. They're really clever because they auto scale. They will, and they will scale down, they will scale up, and they're fantastic. But if you have sustained load on that, you're going to pay a lot more money than you would if you just provisioned the capacity you needed and did your own scaling. So they work really well for small systems or very spiky systems. But for things with sustained load and predictable loads, the elastic scale consumption plans will often be bad for you, but not always. The other example, the Cosmos elastic pricing plan or consumption plan is actually really good. And we find that on most systems, we save money. But all I will say is the good news is most of these you can relatively easily switch back and forth between the different models. So what I always recommend is to just try it. Measure your cost, switch it over to the other model, measure it for a few days, and then switch it back if it's costing you more money. It's virtually impossible to predict what you're going to pay. So it's pretty much the only way of figuring it out. And in most scenarios, it's very easy to switch back and forth. So just try it, experiment. And you might just find yourself saving a fair bit of money and getting a bit more responsive system because you get more scale up as well as down. Okay. Next, sharing. So sharing is caring, as they have taught me. I keep telling you this, but it's my sweets. I don't want to share them. So I actually have come across you. I don't think any of you would think this, but I have come across people who think that they pay for the app service rather than the app service plan, for example, which is not the case. You pay for the app service plan. You can put a lot of app services on one app service plan, especially for smaller systems. You can save a lot of money by just having 1 or 2 shared app service plans and packing everything onto it. There's some clever features that you can use. There's some that's in the portal, some that you have to use PowerShell to do to control how scale of individual, but you can actually control how each individual web app scales with the app service plan and all sorts of clever stuff. The other one is if you have, I have put many Azure SQL databases, say more than 10 or 20. There's a very neat little thing called an elastic pool, which allows you to essentially buy one lot of database compute and memory and storage, and then you can share that across your databases. And that, for when you have like a database per client, that kind of setup, that can save you quite a lot of money, as long as you don't have like a scheduled job that runs on all of them at the same time, because then they're all going to want to use all of the capacity. But as long as it is sort of very individually, they're really good. Front door, good example of something where really favorite tool of mine, by the way, front door. But front door, so front door, if you don't know, it's like a reverse proxy CDN various other security feature thing that you stick in front of your sites. But that one, the routing rules that determine which request goes where, the first 5 are £15 per month each. After that, they're £5 per month each. Now, I find for a typical system or a typical environment, I need about 5 rules. So if I set one up for live and a separate one up for UAT, I'm getting that hit on the first 5 rules twice. Whereas if I just have one front door that covers UAT and live, then I can save about 50 quid a month. Again, not lots, but you know, especially for smaller system, every little helps. Azure Search is another thing. Another example, again, it can be quite expensive to use, and but that is another one that effectively has multiple databases within one price. So again, you can sometimes share that between multiple environments, again, because it can be quite expensive. Okay, nearly at the end of the checklist. IaaS versus PaaS. So infrastructure as a service. So again, VMs, virtual machines, infrastructure as a service. Platform as a service is all of the app service plans and SQL Azure, all of those kind of things. As a general rule, PaaS will save you money over IaaS. Again, with SQL, it's more complicated. And the reason for that is if your code abuses the poor database by doing too many calls and too many badly written queries, SQL Azure will be too expensive because they enforce a very tight performance envelope on you. And you might actually find it's cheaper to run on a VM or managed instance. But if your code is well behaved, then SQL Azure will usually be cheaper and a lot better. You get a lot more out of the box. But one of the real reasons why it's a lot cheaper is that with VMs, you have to make sure you have at least 2 to get the SLA from Microsoft. If you spin up a single VM, there's effectively no SLA. Whereas with PaaS, in most cases, you only need 1 instance. But you got to read the small print to find out. Because Microsoft likes to tell you about all your failovers. So again, app service plans as an example. Sorry, Dan, I know you're not a fan. With app service plans, if you have a single app service plan, even if the underlying VM dies, you get a new app service plan effectively instantaneously. And you have the full 99.97% SLA on it. And so the only reason you might want to consider having two nodes is if you have a slow, cold startup time, but otherwise you really only need the one instance. Things like SQL managed instances is another good example. Again, the way that works is virtualized in exactly the same way. So compute and data storage is separated. So even if the SQL server dies in managed instance, it will instantaneously give you a new one, and it will just carry on, and your application probably won't even notice. But they do sell you the option to have business critical, which gives you 2 nodes. So you've got to look very carefully at the small print and find out when you actually need 2 nodes for failover. And you will find with PaaS, you rarely need 2 nodes, unless you want geographical failover, but that's another whole conversation. And finally, PaaS is just generally speaking easier to scale both up, down, and in and out compared to VMs. You can absolutely do it with VMs, but it requires more work up front. Okay. Abandoned services, again, that's pretty obvious, but you'd be surprised how often you find things that nobody knows what are there anymore, like test environments that are running when they're not in use. And again, just script them so you can spin them up when you need them and destroy them when you don't need them. But also just things that people set up and forgot about. And I believe you me, I've had to go through with it over the last 3 years and tidy things up from the last 11 years. And sometimes it's really hard, because let's say you take a storage account and nobody uses it, and you go in and look at the metrics and it still looks like there's traffic to it because Azure talks to it. So it's really hard sometimes to figure out. So the best thing we've come up with really is to have very clear naming policies. If you go and Google it, there are some really good recommendations out there for a naming policy, which makes it a lot easier to understand where people belong, or so things belong. As a rule, I never let a portal wizard create anything for me, and no dependent resources. I always do them manually, because otherwise they get these obscure names that if you ever created a VM with the wizard, you get a disk with some random name that you can never quite figure out where that disk belongs to. And you end up with these abandoned disks in Azure that you're afraid of deleting because you don't know if anybody uses them. But another really useful thing is teach people how to use resource groups sensibly, so that when you're setting up an experiment, it's in a resource group and you can blow it away. Again, it might sound obvious to a lot of you, but a lot of people don't know this or think about it. And then finally, use tags. So tags allows you to put essentially key value pairs of things. We have a rule that requires every resource group to have an owner tag with the name of the person who owns it, just so we can go and ask them whether they still need it. It's really simple. And then we have an Azure policy, which means that you physically cannot create a resource group in our setup without putting that tag on it. It's not perfect because people still leave, but it at least starts. And it's just a little bit of rules up front can really help you to not have stuff that's sat there spending money forever. And then reserved instances. I always get asked about this one because it's like, that's the big savior. It is and it isn't. It's fantastic for VMs. If you're using VMs, even the smallest VM, you can save money by using reserved instances. There is a concept of reserved instances for PaaS, but in most cases, it only applies when you're doing seriously large scale. So if you think you can get a reserved instance for your storage account with 500 GB of data in it, think again. It doesn't apply to you. It's seriously large scale before that applies. So most of my clients I have to disappoint on the reserved instances unless they use VMs. One other thing where people get excited is that they look at the price of the virtual machine in the pricing calculator, and then they think that they're going to save 30 or 40 or 50% of that. They don't. It only applies to the compute portion. So let's take a SQL VM, which might cost £5,000, and reserved instances might save you £500 or £1,000 a month at most, because the rest is actually licenses. But fundamentally, in the portal, there is a reservations tool. If you can benefit from reservations, it will tell you. So if that doesn't suggest anything, it's because there's nothing to suggest. Okay, it's a pretty good tool. So stop worrying about it. If that isn't suggesting it, give up. Okay. And then finally, this is a small one, but it is one of those little annoying things about locations. So it's easy to assume that Azure services cost the same in different locations, but they don't. As a really good example is app service plans in UK South is about 25% more than in West Europe. Now, you might not have a choice. Your boss might say, no, we have to move from West Europe to UK South, for example, or they might express a preference, but it can actually cost you a fair bit of money. So as a general rule, I always prefer West and North Europe to the UK ones because they're generally cheaper and they're also better. They get the new services earlier and so on. But if you can't do it, you can't do it. Just be aware that you're having to spend a bit more. Okay, that takes me to just shy of 40 minutes. So that's where I was going to suggest you're going to have a break, get a drink, do what you need to do, and then come back. Dan, how long is the break normally for?
About 10 minutes. What time we're in now? So maybe 10 to, I guess.
Yeah.
Does that work? Cool. Awesome. Thanks, Frans. That was, I was going to say that was gold, and it's probably literally gold. It's probably saving everyone here a lot of money. I kind of want to go through all my tenants and have a quick look through, but I didn't want to miss anything. So I won't be sleeping tonight. So I'll just be going through all the portal and clicking through.
Thank you. And well done to everybody for staying awake. I know it's a boring subject, but it is important. It is gold. You're absolutely right. Real gold.
It's not boring when we're all seeing like pound signs.
Like as I said, it's some of the money that people are spending is incredible. So yeah,
it's quite interesting with you were saying about like, the tearing everything down, like UAT environments and stuff over, or QA environments overnight and things. I guess a prerequisite to that is that a lot of companies don't have everything automated. So basically, and if you can tear it down and spin it back up again, and you're doing that every night, then that helps you a lot with the disaster recovery scenario as well.
Absolutely right. If you can script it, that's the ideal. But the scheduled scaling, even if you deallocate a VM, even if you haven't done your VM images, even if you have manually set up 6 VMs and manually logged into each one, right, you can easily write a little script that just deallocates 4 of them every night for 12 or 14 hours. It's really simple to do. And that's what I mean. And you say big with a very little effort there. But what you're saying is the right way. Of course, you want to script it and automate it and images it and all of that stuff. Yeah, you can save without even doing that.
Yeah, it's interesting what you said about like Azure randomly naming things as well. It's kind of, I know with like AKS and stuff, if you just create it in the portal and do everything manually, it creates another resource group with all the managed, like the virtual machine scale sets and stuff. But it's like MC underscore, then this random string, and it's like, oh, call it something nice.
Yeah, and then that's like 6 months later, somebody else tries to find out. So what's that one? Where did that belong to? And can I delete it? And it's like, because again, we have 11 years of history. We went through the, there weren't resource groups in Azure to start with.
Sorry, say that again, sorry.
In Azure did not used to have resource groups back in the olden days.
I'm not old enough for that.
No, there were no resource groups.
I didn't know that.
And you created stuff, and then when they introduced resource groups, everything got put into default resource group 1. So I had literally hundreds of default resource group 1 in different subscriptions and in different places, and it was like, what does this mean? And it took us years and years to tidy it up. So, yeah, fun games. Especially back then when you couldn't easily move between resource groups, which you can today. Yeah.
I'm looking at the chat and this talk of app service, container services. I've not actually even looked at that yet.
What's that?
Azure Container Services. Do you know the thing for that is like managed Kubernetes, and it installs a bunch of stuff on, so it does a lot of stuff for you.
Yeah, the one they announced the build, right?
Yeah.
Yeah, no, I'm the same. I haven't had a chance yet, but it does look interesting.
I'm always nervous about new stuff in Azure because it's kind of like
Yeah.
whether yeah. I think also because I kind of use a K8s anyway. It's kind of is this for people that don't want to learn Kubernetes and just want to be able to throw containers in?
You also need to be careful because after looking at that service, you might need to remove your AKS tattoo.
I think so, but I also think it can be cheaper, right? Because I think the base level cost for setting up your own cluster can be a bit expensive, can't it?
Well, it's exactly like you were saying at the start of your talk. They hide a lot of stuff. So if you go into the portal and try and create a cluster, a lot of the VM sizes for the node pools are like expensive. But if you create it in the command line or bicep, whatever, then you can use a lot cheaper VM.
Not just that, by the way, that's another one of those that caught me out on one of our systems. Somebody had gone through and set up an AKS cluster for quite a busy system using the wizard. They hadn't realized one of the things it does is set up a log analytics workspace and set it up to log all sorts of stuff to it. And I went in and looked, and we were spending £2,000 a month on logs.
Nice.
Just from the Kubernetes cluster. And I was sort of, has anybody ever looked at any of these logs? And they were like, we didn't even know they were there.
Yeah, it's interesting because it's kind of some of the stuff's useful. It's like on a cluster that I'm working with a client, most of the .NET services in there are like using App Insights and just pushing logs to App Insights. That's just like a standard .NET service. But then there's some which are like third-party images where we actually want to be able to alert on just the standard error logs in the container, so actually having those going to like automatically being logged is quite useful. But you're right, it can get expensive quickly.
Logging is expensive, yeah. I've come on to a few horror stories around that. Because, as I said, yeah, we blew. I think they must have been there for 2 years before, because nobody had gone and looked at the cost analysis thing. And as soon as you looked at cost analysis, it was really easy to spot. It was $2,000 a month being wasted for 2 years. So easily done.
When you went through the cost analysis section at the start, some of those drop-down options are so useful, which I've not like. I go in there and look at. I think I filter by service and resource group and type, but I've not gone through like drilling down on all the stuff you showed. So that's super useful.
Oh, that's good. I'm glad that was useful. Yeah, because it's often detective work, just finding out where's the money going. And I wish I could say I always use this combination, but as I said, genuinely, it's so inconsistent what hides under the different ones. But yeah, it's good. It's good fun. It's good fun. Anyway.
I've just seen a question in the chat. Any suggestion to reduce cost on API management and where network cost is high because of making everything private? I've had that thing. So when you're not using the developer plan of API management, if you want to use like private link and everything, or it's just you've got to go premium and it's super expensive. It's like, is it $2,000 a month or something?
Yeah, the only way of using APM cheaply is to go on the consumption plan.
But you can't do VNet integration on the consumption plan.
No, exactly right. There's a ton of stuff you can't do with the consumption plan. But yeah, no, that's why I've pretty much abandoned using APM for that reason, because it's a shame, because it's a wonderful tool. But yeah, as you say, if you can't live with the consumption plan, then you're straight into $2,000 a month. And it's like, well.
What's your thoughts on like obviously, like if you've got an architecture and you kind of like might have a database or a few databases, and obviously can make it private. You've got the connection string and you've got various things to protect against it, but you're protecting based on identity versus actually having to go like make it actual private and using private link and VNet integration and stuff.
I think that with anything new, we definitely always do VNets now. We didn't used to, but it's not either or, it's both. It's, you definitely want both. I don't trust anything else. But yeah, we always do VNets now. It's just, it used to be so hard. And up until pretty much a year ago, especially with PaaS integration to VNet was shockingly bad. so hard to use, and it's only finally just about there. But as you also mentioned, even scripting that, it's hard because it's so obscure how it connects, and I must have spent literally weeks digging into how it all works properly. And you still find there's still things you can't do. Like, here's a stupid thing. If you take a SQL database and an app service plan, for example, one app service, that's an example, and you can set up a VNet and you can set up the private link from the app service to the SQL, and you only have to put a config thing in now for that to work. But then you say, okay, I want to access that SQL database from on-prem. Now, and you don't want to open up the firewall, so you don't want to have any of that. So you want to use a VPN client. But that's great. It's easy to do a VPN client onto VNet. But at that point, it stops working because you now need to spin up a custom DNS proxy in your VNet, because the VPN client can't use the built-in DNS service in Azure. So now you stand up two VMs that runs an 8-line bash script that just forwards all DNS lookups to the built-in one. And you're like, why? So that's my problem with it. It's always painful.
Yeah, it's always DNS, isn't it? It's kind of like
always DNS.
Like for one of the projects I'm working on, I rather than messing around with DNS, because it's just running in Kubernetes, in the pod definition you can specify the DNS address. So I'm just giving an IP address and telling it exactly what to point to, because it's just easier to do it explicitly. That
easy, and as long as you use the host name, because again, with SQL, that was the problem people found, because they were like, oh, I just type the IP address in, but then you can't, because then the certificate names don't match, and blah blah blah. So anyway, no, you're right. VNet peering with VPN and then you can do the host file, Jacob. That's right. But then so you can do that. The other option I said is the DNS proxy, so you can make it automatic. It all depends, and if you're doing it for yourself is one thing. So when I've had to do it for clients, that then they have to be able to maintain it themselves. If I have to start getting them to mess around with host file, it gets difficult.
Anyway. Just reading Jacob's thing. I think what you said there about the hosts is pretty much what I'm kind of like doing with what I mentioned with the pod description.
It's the same thing. Yeah, exactly. It's a point of fragility, but it does work. And if it's your environment, you can absolutely get away with it. But if you need other people to be able to work in it, it might get a little bit more dicey. So it's just annoying. I mean, they'll fix it. You go back 2 years, and the same thing was true for app services. App services, you needed a custom DNS server to use them with private link. They fixed that. They'll fix the VPN client at some point. But also, Jacob, as you're saying, VNet peering it's another whole kettle of worms when you have multi-region VNets, and DNS across those with pass is messy. And anyway, that's another whole conversation, isn't it? Thank you, Jacob. That was really good. And thank you, Jasmine, for the APIM thing. Sorry we couldn't help with APIM, by the way, but it just is a very expensive service. Okay, should we crack on? All right. So architecture. So some choices will really. Oh, it says on the screen. I don't have to read it out. You can make very big differences to cost by just how you do architecture. So there are really 4 things. The first 2, if anybody has seen my lightning talk from February.NET Oxford, you will recognize them. Queues and appropriate database, which are what I say, that's what you need to do for scale and resilience. It turns out it's also what you need to do to save money. It really is the gift that keeps on giving. And then there's sort of 2 more things about scaling out and things about VMs. So let me talk you through these. If you attended the lightning talk about scale, then forgive me, this will be a bit of a repeat for a few minutes. But queues are really the way to deal with stuff in the cloud. What I mean by that is, imagine that this chart shows you this is the load on your site, and it goes up and down and up and down, like this is quite normal. What you would typically do is have provision capacity sitting up here all the time so that you can cope with the load. I think that's a very common scenario. We died it out, but that means that all of this here, this, if you basically were to color in the area above between the blue and the orange graph, that's all wasted money. So you typically do that when you have these traditional, what I call heavy writes. So somebody accesses your site or your system or calls your API or whatever it is you're doing, and they do something to your site, and then that immediately in memory calls out to some other services, does some calculations, do things, and then it writes the stuff to the database. Now, there's a lot of reasons why that's bad, but one of the reasons is that it means that you need to have enough of these running at all times to cope with the maximum possible load at any time. And if you don't have enough capacity, this poor chap here is going to get an error message and his data isn't going to be saved. That's not nice. So what you should do instead is, when this young chap does something, you can do some simple stuff with the database, but only simple things. Anything you have to do that requires work, you put it on a queue. You write a message to say, I've received this input. Let's say the chap was registering for an event. So you take the details that he's put in and you put it on a queue message to say, here's a registration for an event. Do something about it. You put it on an Azure queue, which are dirt cheap, really, really fast, and very scalable. And then you use something else. Usually an Azure function or something. It could be a VM, but something else that then reads from the queue and then does the processing asynchronously from the input. And the reason and that will then go and do things and set it to the database. And the reason you do that is that if there's a big spike in load, it just gets absorbed in the queue. So therefore you get something like this. So you have a provision capacity that is down here, and the load goes way above the provision capacity, but it doesn't matter, because all that happened is that you just get more stuff on the queue for a little while. And then as the load starts to die off, the queue starts to be consumed again. And it's nice and easy. You haven't overloaded your database, you haven't lost any data, you haven't had to have your provision capacity sitting up here all the time. Now, if you want to be clever, you add auto-scaling in based on the length of the queue as well. And then you can start having your provision capacity changing as well, but you don't even need to. This alone can easily, reduce your required provision capacity by 50, 60, 70% very often if you have spiky loads. So that is a relatively small thing, but it's a code change now. Now you're changing your architecture. But that is where I find if you really want to save money in a system that has occasional bursts, this is the first thing to run to, as in code-wise. Once you've done all the other easy stuff we did before the break, this is the thing to do. And then the second thing is appropriate storage. Again, sorry for the repetition. But I mentioned things before about putting your files into SQL, that kind of thing. But there's lots of different database types in Azure. So things like putting your files in blob storage. I have an example, literally system we're working on right now, where we get massively spiky load coming. We have integrations to some external services that will send us events that we have to capture and then process. But it's extremely spiky sometimes. So sometimes we might get 10 in an hour, and other times you might get 10,000 in 10 minutes. And the way the first implementation was done, that all had to be written into Cosmos DB, these interims. It was like capture the event, stick it into Cosmos DB, and then have a processor process it afterwards. The problem with that is that meant we had to scale up our Cosmos DB a lot to cope with these sudden influxes. And we're literally in the process now of just changing it so we drop these interim things into as a JSON blob in blob storage. The architecture is the same. There's still a process on the other side, but by saving these blobs in these interim objects in blob storage instead of in a database, we're going to reduce our bill by maybe £1,000 or £2,000 a month. So that's quite nice. I think I mentioned the system at another talk where I needed to deal with a lot of cars in the system. We had a main database with 6 million cars in it and lots of data, and that was £500 a month to run the database for 6 million cars. we then needed about 200 million mileage records on an additional 50 million cars. Now, I could have created those 50 million cars in Cosmos DB, but it would have cost an absolute fortune again. Instead, we put that into Azure Table Storage and literally paid about £2 a month, £2 a beer a month for it. So really look at those kind of things, especially with large sets of either data that you have a lot of or that is spiky. Look at whether you can use Azure Table and Blob Storage for parts of your system. Okay, it can save you an absolute fortune because databases, especially large databases, are very expensive. Okay, that's the step first. So then onto the new stuff. So scaling out, not up. That's really just general advice. It might be obvious, but I often find people thinking about, well, I can just have a bigger VM and it's great. It really is cool. You can just go into Azure, dial up the thing, and you get 64 cores and half a terabyte of memory and stuff, and it's great. But the cloud fundamentally prefers you to have lots of small computers. Microsoft wants you to do that because it's better for them. It's much easier for them to spread lots of little compute nodes around and move them around as they need than fewer large ones. So they want you to have small ones and you want to have small ones. So that requires you to think very differently about your code. You got to think about, how do you take this piece of work? How do you break it apart into smaller pieces and then fan that out? Whether that's on different Kubernetes Docker containers or Kubernetes nodes or different app service or functions or whatever. But that concept of breaking your code apart into small bits and then sticking queues in between them is really important. And the second thing is, almost always when I need to scale up, it's because of memory, not CPU. Okay, especially true with .NET, because .NET from a CPU point of view is just insanely fast. So it's mostly memory, and that's back to thinking about if you need to process 1,000 records, right? A typical thing that you do, and an easy way is, okay, I'll load my 1,000 records into memory, and then I'll start processing them. But now you need all of that memory to have all of those records in memory. Whereas if you can split that out so that each of 1,000 records gets done independently, and you can put each one on a queue, and then you can have multiple little processors pick them up one at a time and not have them all in memory. That really helps. Sometimes this gets much more complex. I have a client that does deduplication of large databases. So what they really want to do is take a database of, say, 100,000 records and compare each record to every other record in order to see whether they have enough in common that they might be duplicates. Now, you can imagine that the number of possible pairs goes up exponentially. But if you have a big VM, you can feasibly have 100,000 records in memory. And even though it's a lot of comparisons to do brute force, you can feasibly do that in memory. But the problem is you might need 50, 60, 70 gigs of memory. The problem there is, how do you build a system that can do that on demand? Then it gets all of a sudden very complicated to say, okay, when the customer comes and says, here's a database, upload it, we then have to stand up a VM with 50 or 100 gigs of memory, run the thing and shut the whole thing down. That becomes a big orchestration problem because you don't want to have it running all the time. So in that scenario, we then found a way of actually turning the problem upside down. So we could break it into small units and using like map reduce style functionality to fan this problem out rather than trying to do it in memory. But sometimes you have to get quite creative. And if you haven't looked at map reduce, I suggest you look at that. It really helps to sort of think about how to push the work out and lots of small units rather than a few big ones. Yeah, okay, so anyway, once you've done that, queues are good. Can you tell I'm a fan of queues? And durable functions is the other one. Durable functions is really sort of just an abstraction over queues, believe it or not, but it does have some very clever things in them. There's very little you can do with durable functions you can't do yourself with queues. So just look at them both and figure out which ones you prefer best. The one thing dual performance does really well is fanning back in, but that's another conversation. But for a lot of the times, do one of the two. Okay, so that's that. As I said, just constantly think about scaling out, not up. As soon as you start thinking, we'll just have a bigger machine with more memory, try and stop, try and redefine your problem. That's hard, but it's usually worth the effort. And then, so this is simply what I mentioned about distributing the work in small chunks. So quite often we'd have something like this get a thing coming in, put one message on a queue to a function. That one then goes and looks up some more data. And then he says, okay, so let's say back to the event registration. We might actually say, well, I need to write that back to the database, but I also need to do some payment processing, and I need to send out an email to respond to the person, say you have been registered, and I need to book the caterers or whatever. What we would typically do is actually split even those bits up into individual pieces of work that also go on a queue with different functions. It sounds a bit crazy, but it means that you have a system that will really scale, and it actually is much easier to think about because it's back to the encapsulation thing. It's almost like nanoservices or whatever the latest buzzword is, but sort of that way of thinking about it. The one thing to be wary of is if these things here all start updating the same database records. That is something I have run into. You can get into concurrency issues here if they all end up wanting to update the same person record in the same database. That can get quite painful, so do be mindful of that. But that's it. And then, as I said, the bonus is this works super well with auto-scaling because you can put auto-scaling on all of these things. Finally, on that one, just don't use VMs. Friends don't let friends use VMs. Use Kubernetes or use PaaS. Don't use VMs. They are too much to own. They're too expensive. Just don't do it. Okay. Now I have one more thing I want to talk to you about before we wrap up. I guarantee you, all of you are going to say, no, we don't do that. So I'm just telling you now, everybody I go into and say that we don't do this, and they're usually wrong. So chattiness, this is what it is. So let's say you have a user who does something in your application. In this case, I've imagined it's a spa that runs in the browser. Forgive my poor graphic. So the user does one thing, and then this spa does 10 API calls up to your API. And your API server here then does 100 database calls, right? The problem with that is, if that happens, that's expensive because this one interaction is 100 database calls. That means you're paying a lot of money for that database. There's something you're not doing right. And I know you're going to tell me that that this doesn't happen in your application. So I dare you to stick application insights on your app if you don't already have it. If you can do it, add this JavaScript snippet on the front end that's part of App Insights, and then run this query. This is on my blog. You can find it on there. So I'm going to show you my dirty laundry in public. I'm going to show you what this looks like on one of our own old applications that's running, and it has a bug in it. Oh, hang on, bear with me. Why would that not? Hang on, let me open it from the other screen. I thought that would work. Here we go. This is live. This is a live demo. So what that is showing me, so these are individual API calls. So this shows me that API call that an actual user did took 15 seconds to run. It called the SQL database 4,170 times. And the SQL, it took 9.5 seconds of SQL execution time. This is a live system. You know, this thing down here, we did a little post. That was 3,786 ones. Now, this one, these are individual requests. I haven't aggregated them on purpose because for this particular query, what I want to be able to do is to then take the request ID and then go and find that in the logs and find out which user it was and which client it was, because then I can take that exact request with their parameters, and on a copy of live, I can then rerun it and step through and see why the heck it is talking to the database for 4,170 times. Okay. I hope that makes sense. Now, believe it or not, that's one of the most common problems we see. And every single time I ask the devs about this, and they say, no, we don't do that. And then I show them, and they're like, oh. Now, so as I said, I challenge you to test this. So the two reasons for it, generally speaking, is select n+1, and that's better with EF core. It's less likely to do it, but typically it's the one where you select the row of records, and then you're looping over them, and you're usually finding like a navigation property or something else, which means that the ORM will quietly go back to the database for every single record. So if you select 100 records, you end up doing 101 calls. Or, as I've seen in some cases, every record goes back about 4 times. So 401 calls back to the database, when it should have been a single SQL call. It is extremely easy to do because your ORMs will let you do it very, very easily. There are some tools that can help you identify that at runtime in your dev environment, but it's the best one was Glimpse, but that is sadly no more, or at least not very much. Oh, thank you, Jasmine, for posting the blog post. Brilliant. The other one is caching. So I had a client where we went in and we looked, and they had a system which was not even that busy. And they were hitting the database 5 million times an hour during the day and 10 million times an hour during the night. And when we looked at it, it was because they weren't caching some config settings. Most of the 2/3 or so of the SQL calls were looking up the same 5 configuration values from the database. The reason it was more at night was because they were running batch jobs at night that were just reading all these config things. Now, so that's one about just doing a little bit of memory caching to keep these things so you don't look them up every few nanoseconds. Do be mindful, don't fall into the trap of, oh, it's cached. Oh, and we're cloud and we need distributed caching, right? Because just think that one through for a minute. Rather than looking it up in the database, you're now looking it up in a network cache. So for stuff like that, you want in-memory cache that's local to each machine, and you just need to decide with yourself, how long is it okay for 2 machines to be out of sync on a config setting? And in most cases, a few minutes is probably fine. So these guys literally, as I said, they were looking up the same config settings 5 million times or millions of times an hour. 2 minutes of caching of that in memory on each node would have cut that by 80% kind of thing. And as I said, I know you think you're not doing it. Test it, okay? Just do me a favor. Just one big warning. App Insights causes login costs. You can actually also, you can switch on App Insights. There's another thing you can also do, which is you can tell SQL Azure and Cosmos DB and Front Door and everything else to log directly to Log Analytics. And that's really helpful to detect all of this stuff. But as this client was the 5 million calls an hour, we switched that onto the SQL database to log all the queries and left it for a few days. And that cost £5,000. So there is a cap that you can put on your Log Analytics workspace. Yeah, do that. Okay, do that. So you just tell it, once you get to 2 gigabytes, stop logging and stop charging me money. Please do that. Okay, I've given you the warning. And that's it. So to conclude, measure first. Don't just start saving money. Don't start ticking all the boxes you've read on the crib sheet somewhere. All the stuff I've told you to do, don't do any of it before you measure where your money is going, because you're just going to waste your time. Secondly, once you've measured, make sure you use the right kind of service and at the right scale. Don't use premium unless you need to. Don't use business critical unless you know you need to. Don't use read access, GRSZ, whatever, unless you know you need to and you actually write the code to take advantage of it. See how little you can get away with. Try it. It's always easy to change it. And then actually optimize your architecture for the cloud. And that means, as I said, scale out, small stuff, that kind of thing. Okay, so that's all I have to say. I wanted to say again, if you want somebody to come and have a chat to you about this, we work with a lot of companies. Ping me a message. We're happy to have a call for an hour or two. Just we never charge for that. Just to sort of talk through what you're doing, discuss whether we can help, and if we can come in and maybe do a bit of a deeper one, and that kind of thing. And if you were ever to become a customer of ours on the Azure reseller side, it's sort of part of the service. We do that kind of stuff as part of at a discounted rate when we do it. So I think that was the sales bit done. We can get on to questions. Anybody have any questions? Well, that was easy. I think there was one in the chat. There was Andy saying scaling out reduces the effect of outage. Yes, you're right about the scaling out, Andy, especially with VMs. Exactly right. Okay.
Just out of curiosity,
Yeah.
in your own example where you did that query in App Insights that said like, what was it, 4,000 things?
170, yeah.
Do you know what that was?
I haven't looked at that particular one, but that will from what I know about that particular, that will be a select N+1. Well, except it's one of those where it will retrieve a row of records and then it will go back and get another 10 things per record. There's no question.
It's quite interesting that you mentioned about Entity Framework, just seeing like what it's, as you say, it's a lot better now, but just seeing what it does behind the scenes.
Yeah, so exactly with EF Core, you don't have the lazy loading by default anymore. You have to switch it on, and that helps a lot. But people still do it. I've seen them do it, and sometimes, especially junior developers, they don't think about sometimes what they're doing, and because so few people have been brought up with doing databases directly, so they don't know how to use the tools to monitor what they're doing. And I've literally seen select N+1 with Cosmos, because the developer literally wrote the loop that says, I'm going to go and get the records, and then for each one I'm going to go back and get this one thing, this one other record. And you're like, something is wrong here. It might be a data model, but something is wrong.
It's interesting with the Entity Framework stuff. I was chatting with Sam Crop with his snapshot testing library, and he's got a bunch of extensions. One of them is for Entity Framework, and basically, if you can run your integration tests, and then it will basically track all the Entity Framework SQL calls, the real SQL calls, and generate a snapshot from that, which you can use in your tests, so you can actually see what's the actual SQL that's been called. And then if you upgrade Entity Framework in the future and Microsoft change the SQL that will be generated under the hood, your test will fail and you can actually see the SQL that's changed. And it might be a good thing. It might be a performance improvement they've made, or there might be an issue which is actually meant the SQL's suddenly gone horrible. But because it's in your test and you can actually see it as part of the snapshot test, that's so useful.
That's a really good shout. Absolutely right. Yeah.